Okay, this is recording on the second part of chapter 20, alcohol and carboxylic acid. So this is carboxylic acid. Under carboxylic acid, later we also learn about esterification as part of reaction of carboxylic acid and alcohol. So what is carboxylic acid? So carboxylic acid is the fourth family that we study, the fourth family, which is the organic compound that contains the carboxyl functional group. So what is carboxyl? Carboxyl, you can see a typical structure of carboxyl is like that. Okay, it doesn't mean you must draw at this angle. You can always draw like, for example, I draw this carbon, it can be like that. Double bond up and then O dash H towards the behind. This will be neater to draw rather than drawing at the angle. This will be neater to draw. So usually I will draw the carbon, double bond is up and then the OH at the back. Now recognize that when there's a double bond O and there's OH, I cannot say the OH is hydroxyl anymore because there's a double bond O here. So together it's called carboxyl. Carboxyl. Alright. And in this carboxyl group, it's very interesting that the last hydrogen can ionize actually. If you put in water, the last hydrogen can ionize to form H plus ion. That's why it's called acid. So the general formula you must remember is CnH2n plus 1 COOH. Now, in this formula, there's a carbon at the back in the functional group. So my N cannot start with 1. If it's 1, you realize there are 2 carbon. 2 carbon already ethanol acid, which is this. See, 2 carbon, ethanol acid. If I want to have only 1 carbon, so the only carbon come from the functional group, the front must be a 0. So N must start with 0. So when N is 0, C0, H 0 plus 1 is 1. So it's HCOH. So take note, the N's actually start with 0. And N, after that N equal to 1, N equal to 2. So the name is not based on the N. The name is based on the number of carbon in the molecule. Alright, so methanoic acid means 1 carbon. Ethanoic means 2 carbon. Just like methane is 1 carbon. Ethane is 2 carbon. Methanol is 1 carbon. Ethanol is 2 carbon. So the me, e, prop, build is the number of carbon. So always remember, whenever you put the 1 inside the N and you write the formula out, becomes CH3COH, you must quickly recognize that this is already a second member. It's called ethanoic acid. And if you're required to draw or write methanoic acid, then of course you make the N equal to 0. Alright, always check. Alright, so down here is the first 4 member, and they're all liquids because the boiling point is above room temperature, just like alcohols. So you realize that the first 4 member alkane are gases, and the first 4 member of alcohol and acids are liquids. Okay, good to know that. Okay, remember that. So down here again, they have actually relatively low boiling point, okay, but it increases as the molecular size increase. So again, we talk about the intermolecular force. So the boiling point increases down the series. The intermolecular force of attraction increase as the molecular size increase. So whenever molecular size increase, the intermolecular force increase according to the theory, the facts that you learn under simple covalent molecules. So when the intermolecular force increase, the energy, more energy is needed to overcome this stronger intermolecular forces. Therefore, the melting boiling point increases down as the molecular size increases. Alright? And carboxylic acid are soluble in water. Remember, ethanol, alcohol, the smaller alcohol are soluble in water. The larger one are not soluble. Now here, similarly, carboxylic acids are soluble in water. That's why added in water, they form what? They form acids. Okay, for example, the most commonly used one is ethanoic acid. We see that every day in our life, daily life. A common name for ethanoic acid, which is not the pure form but mixed with water, is called vinegar. Vinegar. Alright? So this is our vinegar. The one that we eat, okay, we add our food for flavoring. Vinegar is actually ethanoic acid. Okay, let's move on. Alright, so remember our acid can be produced by oxidation of alcohol. Okay, now we learn about the chemical reaction first. So first of all, I think when you look at the word acid, you know that they have hydrogen ions. So what happened is the carboxylic acids are weak acids because they ionize partially in water. The keyword is ionize partially in water. And they form carboxylate ion and hydrogen ion. Remember hydrogen ion. What is carboxylate? If you don't remember the word carboxylate, at least remember like ethanoate, propanoate, methanoate. So to make it simple, when you see ethanoic, okay, you see that IC at the back? IC change to ATE. That's the meaning of the carboxylate, ATE. Okay, ethanoic change to ethanoate. Methanoic acid will change to methanoate. So IC change to ATE. So I remember this way. I remember by IC change to ATE whenever you turn into the ion. Okay? Just like chlorine turn to chloride, IDE. They all turn to IDE. But down here all turn to ATE. Yeah? So that's the way I can remember the name. In simple, you look carefully at the only hydrogen ion on the functional group, carboxyl functional group. Other hydrogens are not detachable because they are all joined by strong covalent bonds to the carbon atom. They're all strong covalent bond. This is the weakest one down here. Okay, because of the interaction of the oxygen, okay, that is attached to this carbon as well as the O then H. This bond here is the weakest, and therefore this can be ionized to form hydrogen ion. And because it ionized, this is acid. So a metal ion forms a salt with carboxylate from the carboxylic acid. So for example, ethanoic acid, let's look at example, ethanoic acid, IC acid, change to ethanoate. And the salt is always metal first, followed by the name of the acid. So remember, if it is sulfuric acid, it turns to sulfate, right? Sulfuric, sulfate. Is it similar? Sulfuric, sulfate. Now it's ethanoic, ethanoate. And the metal is always in front. But in the formula writing, you realize metal is written at the back. Yeah, the metal is written at the back because it replaces the hydrogen at the back. See that? It replaces hydrogen at the back. So sodium replaces hydrogen at the back. So you know that this anion is a single minus. Just imagine it's like a chloride. So like a HCl, except opposite direction. Instead of writing HCl, write ClH. Like this way, you know. Imagine ClH. And here is ClNa instead of NaCl. So basically, it's very similar to writing equation of HCl, except that the H and the anion change position. Likewise, for the salts, the metal and the anion change position. Alright? So if I want to write a magnesium ethanoate, how do I write? Remember my ethanoate is like that. It's a single minus. And I combine with magnesium is 2 plus. Obviously, like this. Why? Because my magnesium chloride is written as this. Just in your mind, you can work this way. You can work like, oh, I just always imagine that it's like the acid is like the chloride. So imagine that the acid is written as the chloride, but in the opposite way. See that? Written in the opposite way. So isn't it this the bracket for the organic acid? Yeah. So very interestingly, organic compound, the formula is written in the opposite because we want to emphasize that the hydrogen at the back. So the magnesium is at the back. But likewise, this is always a single minus because it only produces one hydrogen ion. Each time you ionize, you see this equation? Point here. Each time you ionize, you only form one hydrogen ion. And some more is a double arrow to emphasize it's partially ionized. Probably about 1% ionized only. So partial ionized simply means that the moment I react away, more will ionize. They react away, more ionize. So ionization continues as more and more of this hydrogen ion is used up in the reaction with things like metal or carbonate. So if you don't use up, you maintain about 1%. So you use up already, you still try to maintain 1%, but you move, the equation will shift towards the right hand side. So more and more ions will produce. Eventually, every single acid will be reacted. So you must be careful about weak acid. Weak acid don't have all the ions formed at the same time. So the reaction will definitely be slower, right? So when you react, you form more ion. React, form more ion. So this H plus will be formed until all the acid has been ionized completely. then the reaction will stop. Yeah. Alright. So now here is writing equation you need to know how to write. So basically, if you know how to do this thing, there's only 3 things you need to know. 3 things. First of all, the acid react with reactive metals to form the carboxylate salts and hydrogen gas. It also reacts with metal carbonates to form carboxylate salts, water, and carbon dioxide. Last but not least, the acid also react with bases to form the carboxylate salts and water. So basically all these are all these are acids reaction, right? Acid with metal form salt and hydrogen, except that now we call it carboxylate salt. React carbonate to form salt, water, carbon dioxide, but now we call carboxylate salts, water, carbon dioxide, and with bases to form salt and water, but now we call it carboxylate salts and water. Okay, it's all similar. Alright, so this one you just need to go through a bit and then digest it. Now another one I want to highlight here, which is very important and commonly tested, is the esterification, which is next part. So here are all metal acid reaction. Here is reaction with esterification. No, not reaction ester, reaction to form ester. So acid react with alcohol to form ester and water. You just salt the water, but now it's called ester. Alright. Ester is not like, like the carboxylate. But down here you realize something special. It's like in this case like ethyl ethanoate. Ethanoate looks like the salt, right? Ethanoate looks like the salt. But instead of a metal, this is ethyl. Alright. The name comes from alcohol. Can be methyl, ethyl, propyl, butyl, all come from the alcohol itself. Okay, and this one we will learn a bit more. Alright, in detail later in the next section. So just need to know that acid and alcohol form esters and water. And ester is very typically sweet smelling. It can like flavoring, making some kind of smell, like fake ice cream, with banana smell, pineapple smell, whatever kind of smell. They're actually esters. Actually, esters can make into smells that you thought it is a fruit, but it is not a real fruit. It's fake one. It's just that this chemical has a smell of certain fruit. Alright, so we'll touch more ester in the next section. Okay, just know that there are 2 main reactions of acid. One is behaving as an acid with metal, carbonate or base, and then finally acid with alcohol to form ester and water. Now let's talk about forming of ethanoic acid. Down here we will emphasize on these 2 differences. Remember we learned about ethanol being oxidized to form ethanoic acid. If it's methanol, you turn methanolic acid. And this 2O refers to oxidizing agent. So I have acidified potassium manganese 7 acting as an oxidizing agent. So this is OA. This is OA. But this is air. Remember, air can oxidize. That for example, a metal can oxidize in air to form metal oxide. So this air's oxygen also can oxidize my ethanol to form ethanoic acid. So in the presence of bacteria, so important take note, there must be presence of bacteria in the air. So together bacteria and oxygen, this bacteria actually will have, I guess, probably secrete certain kind of enzyme thing. They actually help to oxidize the ethanol in the presence of air, reaction in air, to form the acid and water. So these 2 equations is almost the same. Basically, all alcohol, when oxidized, you form acids. So ethanol acid, the number of carbon cannot change. I repeat, on oxidation, number of carbon cannot change. So ethanol acid, propanol acid, butanol acid. You must remember that. Okay, the number of carbons remains on oxidation. Okay, now what's a common mistake? I already emphasize here. 2O is the oxidizing agent. The oxygen comes from oxidizing agent, which you don't want to write the complicated formula. If I write potassium manganese 7 here, then behind here, the second part equation also must write, the manganese 2 ion, manganese whatever thing is complicated. No, I don't want to do that. I just want to write that 2 oxygen is added here, alright, and hydrogen removed to form water, and so on. So this is oxygen from the air, O2. So what's the common mistake? You look at this equation here. Oxidation of ethanol in air represented by this equation. So look very carefully. In air, how can I have 2O? 2O doesn't mean in air. 2O is oxidizing agent. So in air must be O2. Remember that air oxygen is always O2. That's all. The rest are the same. Okay, so the explanation is bacterial air acts as a catalyst. Of course, bacteria has a biological catalyst, which is enzyme. Okay, speed out reaction between ethanol and oxygen, and therefore ethanol reacts with oxygen, not with the oxidizing agent. Oxidizing agent is a symbol bracket O, but in this case it's O2. Okay, so very simple about the carboxylic acid. 4 reactions, right? 2 category. One is behaving as acid, reaction with metal, base, and carbonate. The second reaction of acid is with alcohol, which is esterification. Yeah, so you'll learn more of it in a short while. So let's look at this question now here. A sample of propanol is used to prepare sodium propanoate in 2 steps. Sodium propanoate. Alright, so no effervescence observed. So you propanol react something and then something. What do you think this can be? Because my propanol doesn't directly go to propanoate unless I got propanoic acid. So I will think that the compound B must be the propanoic acid. Acid can then form the salt. This is a salt. This is a carboxylate salt. I know it may not be familiar name, but you need to memorize slowly. Propanoate is a carboxylate salt. Alright, so it comes from only with the acid. It doesn't come from alcohol. So alcohol must turn to acid, which of course A is oxidation. And you form propanoic acid. And propanoic acid react with something to form the salt. And no effervescence. No effervescence means it cannot be metal. It cannot be carbonate. It can only acid-base reaction, no effervescence, right? So my reaction C here cannot be with metal or with carbonate because no effervescence. So I use metal and acid and base reaction, neutralization. So reaction is neutralization. All right. So look carefully here. Oxidation helps me to convert my propanol propanol to propanoic acid first, and the reagent needed is of course oxidizing agent. Okay, you don't leave it to air to oxidize. You realize that the air example is to oxidize ethanol. Alright, but of course air oxidation is very slow. If you want to oxidize propanol and so on, actually those are not in your syllabus. You just need to know that ethanol oxidized by air. The rest you just think that they oxidize by oxidizing agent, which is a faster reaction. You can do it in a lab. So once oxidized to acid already, I can react with a base to form salt and water. The reason why I choose a neutralization and the base because there's no effervescence. So cannot be a carbonate or acid or a metal. Okay? Yeah. So such things you need to understand how to apply. Now we come to the last part. Okay, this can be considered as a third part of this chapter, but this is actually part of a carboxylic acid. Why? Because this is a reaction, one of the typical reaction of carboxylic acid. It is also a reaction with alcohol. Well, why do you study under carboxylic acid? Because if you don't know about acid, then you cannot combine with alcohol, right? So after we learn about how alcohol turn into acid, we also learn that how this alcohol and acid together can react also to form an ester. So what is so special about ester? So ester is a compound formed between the acid. Okay, what am I doing? Between the acid and alcohol to form an ester. Okay, so let's see. This is a ester functional group. Now it looks so familiar. If we can recall, it looks exactly like this. What is this? This is called carboxyl. But the carboxyl has a hydrogen at the back. This is carboxyl, XYL. Carboxyl has a hydrogen at the back. And carboxyl can ionize to form what? Form hydrogen ion. So as long as you got carboxyl, it means that COO joined to a H. But I got COO here, then what am I joining to if it's not a H? Yeah, so remember, you join to other carbon. It is in between carbon. So you find carbon on this side, carbon on this side. Even if you find hydrogen on this side, it's fine, you know. Because if I have a hydrogen on this side, this hydrogen is connected to this It's not going to ionize. It's not going to be like the carboxyl. Carboxyl is when a C double bond O, then OH. OH. This become weakened and can be ionized. But if you join the H direct to C, then this one is a strong bond. It will not be able to break, it will not ionize. So it's not called carboxyl. As long as this O don't join a H can already. If you join a H, it must be called carboxyl. If you join to carbon, it's called ester. Alright, COO, the O joined to a carbon is called ester. So let's look at ester. Now, generally, you need to know a few properties. Very interestingly, they are actually volatile. They can use as a solvent. Sweet smelling. In fact, their smell can be smelled like fresh wood, certain kind of flower or one kind of thing. This is a very distinctive smell. And the best thing, they smell like some fruits. The fruity smell that can be used as a flavoring. It's insoluble in water but soluble in organic solvent. Typical molecular organic compound. Neutral and less dense than water, can float and unable to conduct electricity because simple covalent molecule. So the reaction is this. The reaction is called esterification. So what's esterification? It's a reaction between the acid, okay, and alcohol in the presence of consulfuric acid to form ester in water, and this is a reversible reaction. Now this one is a bit heavy in content, okay, but can memorize properly one. Acid, carboxylic acid plus alcohol, heat in the presence of consulfuric acid, they can turn to ester in water, and this is a reversible reaction. Okay, so what happens is this. You need to know how to draw the ester. Key thing is draw ester. Writing equation, seldom. Drawing this structure, very often. Even naming the structure, recognizing what is the component that combine to form the ester, you also need to know. Alright? So look carefully here. I'm going to highlight the functional group. Look very carefully at the functional group. I'm going to highlight one in blue and one in yellow. Now, if you realize the yellow color is called COOH, this is the carboxyl functional group. The OH is hydroxyl functional group. So carboxyl and hydroxyl, they will make ester. Carboxyl and hydroxyl will make ester. So when they come together, in the presence of heating and consulfuric acid, heating is about 100 plus degree, probably 100, if I'm not wrong, it's 180 degree. But don't need to be so specific, just say heat in the presence of consulfuric acid. Look at this. The bond here will be broken. Now, very special. Do you remember we used to break this OH bond? O to H bond. And this one form what? Ions, right? As acid. But now you don't break this, you break here. Alright? So you are breaking this bond to remove OH. You are breaking this bond to remove H. Now this OH bond here actually is covalent. This covalent, oh, this is a strong covalent bond. It doesn't break easily by itself. Alright, unlike this OH here, I'm pointing to this OH here, O to H bond, this is weaker and it can ionize in water, means it breaks down in the presence of water to form H plus and this ion. Okay, the carboxylic ion and the hydrogen ion. But down here, when I heat it with consulfuric acid, I break this bond, memorize that, break the OH away, break the H away, and they combine to form water. There you are, it forms water. You see that? So this forms the water. And then this C double bond O will then join to the O to form this. So you look carefully here, this is actually the highlighted, okay, and this is the blue color which I highlighted also from here. You break out the OH and H to form H2O, and you join together to form ester linkage. And remember what I mentioned, COO, the O cannot join to H. Yes, it's correct. Join to C is correct. This O must join to a C. It cannot be a H. Alright, so it's called ester linkage. So why it called esterification? Because the reaction breaks out the water and it forms the ester linkage. So this is called esterification. Now, the next thing is that how do we even name? Okay, anyway, sorry, I forgot to mention one part. This is forming a water. Forming a water in the process is called condensation reaction. Condensation. Just like water condenses out from the air. Okay, the water condenses out from the reaction. Alright? So it's called condensation reaction. So esterification is also called condensation. Why? Because in the process of forming the ester, you also form water as a byproduct. That's why it's called condensation. Now, once you form this ester, then how do you remove this ester from the reaction mixture? You use distillation. Okay, distillation. So the formula is complicated. Okay, look at this. This looks complicated, but don't worry. Do you realize that the center part is the one that you need to remember? Both sides is CnH2n plus 1 on both sides. Center is COO, which is ester. Now, then which side is the alcohol, which side is acid? Always look at COO. Look at this SCO. When you see the COO, in order to recognize who is acid, who is alcohol, I do this. Look carefully what I'm doing. I always cut the ester linkage by the middle. I cut the middle such that both sides has one O. One O here, one O here. So if I cut exactly here, I got one O on this carbon. I got one O for this side. The double bond O carbon one must be the acid. Why? It was a C double bond O then OH. So if you see this thing, you know this side is OH. If you see a single O cannot be the acid. Single O must be the alcohol side. Alright, so I give you any ester, you cut exactly in the ester linkage in the middle so that both sides has one oxygen. The one that has double bond O is the acid side. The one that has a single O is the alcohol side. And knowing the acid side, alcohol side, I can give the name already because the name always start with the alcohol side and the acid side. Remember, ethanoic acid. Okay, the second part of the name comes from acid because ethanoic acid. Remember IC acid, it turned to ethanoate. So the carboxylic must have come from the acid, carboxylic acid. The other side comes from the alcohol. So this ethyl means it comes from ethanol. This ethanoate means it comes from ethanoic acid. Okay, I repeat. You take the ester linkage, cut exactly the center. Each side must have one oxygen. The one with C double bond O, you can put back OH here. So it becomes acid. There are two carbon, is called ethanoic acid. So it must come from ethanoic acid. On the other side, I have O, I put back a H, become alcohol. This is two carbon, it's called ethanol, that's why it's called ethyl. Once you form the compound, it's called ethyl. So alcohol will be named before the acid. Okay, alcohol is named before the acid. Okay, let's go through more detail about the naming. Okay, so you know that given a molecular formula like that, this is actually part of structural formula. What I'm going to do is this, I'm going to cut exactly between the two O. The side with a single O must be the alcohol side. If I see two carbon here, it's called ethanol. If I see three carbon here, I call propanol. If I have four carbon, it's called butanol. The CO, C double bond O, this side is acid. If I count the carbon, for example, there's N, let's say there are three carbon in front, plus one more is four, I call it butanoic acid. Come from butanoic acid. Alright, if it's two carbon in front, C2H5, let's say C2H5, and there's one more C, right? Means C3 altogether, means propanoic acid, propanoic acid. Okay, so don't worry, we'll come to the naming now in detail. The name has two parts. Okay, the first part comes from alcohol, the second part comes from carboxylic acid. Yeah, you know, stereotyping, you always watch movies, stereotyping is that the man always wants to drink alcohol, right? They think it's very cool to drink alcohol. So I would say that, okay, to remember this thing, okay, not to really stereotype, but just to remember, the alcohol like represent the male, represent, in our society, in our Chinese society here, our name, surname come from the man, from the father. So the first part of the name is always from the man, which is drinking alcohol. So the first part of the name comes from alcohol. Alright, so look at this. This is alcohol. Alcohol has one carbon. So you call it methyl. Okay, alcohol one carbon called methyl. Then acid side. Okay, actually it's quite true that I observe is that acid. A lot of ladies like to eat food with vinegar. Yeah, I don't know why. Actually it's quite nice actually if you put vinegar into noodle. In fact, a lot of like my lady friends, they like to eat noodles with vinegar, and I always remember, okay, maybe the female side will be the vinegar. So the man's surname, the female give the other part name. So here has 2 carbon. 2 carbon means ethanoic acid, means the name must be ethanoate. So very simple. The alcohol side will give you the first part. The acid side will give you the second part. So you count the carbon. If 1 carbon, methyl. 2 carbon, ethyl. This side 2 carbon, methyl, ethanoate. If 3 carbon, it's called propanoate. That's how you derive the names. Okay? So let's look at this. There are 2 esters down here. How do I even call them? So follow me. I take the cutter. I cut exactly in the middle of the ester linkage. Cut exactly in the middle. You realize that, hey, I got alcohol side with 1 carbon. So it's called methyl. Acid side, this is of course acid. C double bond O, even though it doesn't look like acid, but if you add the OH to it, it's still an acid. So methanoate become methanoate. Simple, right? Next one. I'm going to draw a box around the linkage. I'm going to cut exactly in the middle again. Then you look carefully. Alcohol, O is alcohol side. 1, 2 is called ethanol. So it's ethyl. This side, double bond O is acid side. 2 carbon. So it's ethanoic acid become ethanoate. So very simple. Okay? So that's how you name it. Alright, all these are structural formula. Even the below one is called structural formula. Then what is my molecular formula of this? Now interestingly, if you write a molecular formula, you must combine them together. Let's combine together. I will write this way first as my working CHO. Carbon has 1, 2, 3, 4. C4. Hydrogen has 3 plus 2, 5 plus 3, 8. And this is 2. So this is called the molecular formula. Okay, molecular formula. And I can reduce to a simpler form called empirical formula. So if they can reduce, sometimes they will ask you, this is called empirical formula. Okay, empirical. Okay, so this is empirical formula. Okay, alright, let's move on. Okay, let's look at this word example. Ester made for ethanol and propanoic acid. Always underline the name. In fact, at one look, I know what's the name of the ester, right? The ester is going to be ethyl and propanoate. Okay, it's very interesting. You see, it can make artificial pineapple flavor. Now, really, you know that ice cream made of this flavoring for ester is just ice and some flavoring for ester, and then some coloring that make it yellow. It looks like pineapple kind of ice cream. Yeah, it's a stick. Yeah, it's like that. Or you can make into flavoring that you can make into, like, for example, pineapple, enhance the taste or the smell of the pineapple tart. Yeah, so you can make the smell stronger and better for pineapple flavor. So I will draw the full structural formula of this ester and write the chemical equation for the formation. Interesting, right? Full structural formula. So first of all, you must recognize that there's ethanol. Ethanol, if you remove a H, this is how it looks like. Ethanol without the H. Right? Then the propanoic acid has 3 carbon without the OH. So this is propanoic acid without the OH. Wait, oopsie. Okay, so you look carefully here. Smaller a bit. Wider a bit, yeah. So I have removed the OH from here, but the 3 carbon is called propanoic acid propanoate. Here is 2 carbon. This is ethanol or ethyl. So ethyl propanoate is like that. Alright, this is the final answer. This is not working. Working, basically you need to draw the ethanol and draw the propanoic acid. Ethanol remove H, acid remove OH, join together. Now, they want the chemical equation. So chemical equation is like that. Okay, you can write in this way. It may not be molecular formula unless it asks you for specifically write the molecular formula. Then you have to group them together like that. Molecular formula. If not, you can write like that. It's fine. This one shows clearly an alcohol, an acid forming an ester. You see that? And of course, water is produced. So some MCQ question can be very difficult if you don't remember. Like for example, When do you form water in the process? When do you form carbon dioxide? Remember, our fermentation produces what? Carbon dioxide. But down here, esterification produces water. So you must remember this minor detail, not just the main product, but also the minor detail, like what else is produced. All right, so this is the chemical equation. All right. So let's look at some example. Okay. Now, oh, this is the word example. I need to explain. Okay, never mind. So maybe, okay, I'll just pause here for a short while. Pause my. Okay, I hope you have tried this question. Now down here, what is enthalpy change of combustion? This one, and this basically energy change. So when you have a formula like that, maybe I should just write out an example. I use the first one, CH3OH plus O2 will form CO2 plus H2O. Alright, so let me try to balance this. Okay, 4. Okay, it looks like I need to multiply 2 throughout. Okay, let's put it 2 in front. 2, 2, 4. Okay, so down here I will have 2, 8, 3. Okay, let's check. 2 carbon, okay. Hydrogen, 8 times 2, yes. 4 times 2, 8, correct. Oxygen here is 6 plus 2 is 8. 8 is correct. Yeah, so this is a balanced equation. Let me try the write the other equation. Let me write a big one. C4H9OH plus O2 will form CO2 plus H2O. Alright, so let me just try to balance again. Put the 4. Looks like I need to put 2 in front again. Okay, let me put 2 in front. Okay, I need to double this. I need to put 8 here. And then hydrogen is 10 times 2, here times 10. And then oxygen will be 2. Yes, 8 times 2, 16. 16, 26 altogether. Minus 2 for the front. 24. So that I have 12 here. Yeah. So I will have this. Okay. Now, why is it that the enthalpy change increases? You realize I'm breaking the same kind of bond, which basically down here is a C to H bond, C to O bond, and O to H bond, as well as the double bond in the oxygen. And I'm forming the same kind of bond, which is carbon to oxygen double bond. I'm forming the O and H bond. But look carefully here, the first equation, I break 2 molecules of this and 3 molecules of this. In the second equation, I still got 2 mole here, okay, but I actually they go by per mole, right? Energy per mole. So 2 mole, yeah, good comparison. They're same number of mole, but the amount of oxygen here you break is more than this, and form even much more. So you see that whatever you form here, whatever you give out here, okay, this is exo, right? Exo giving out, and this is endo. You absorb to break, you give out to form. Again, endo, absorb to break, give out to form. Now, down here you're forming much more of the similar kind of bond. For the same mole of 2 mole each, I form much more. I may break a bit more here, but I'm forming much more compared to this. That's why it's much more exo here compared to here. Alright, of course you can count the bond energy individually, but it's not necessary lah. Okay, so for similar kind of compound, you realize that if I break more bonds and form even more bonds, if the initial one is already exothermic, ultimately it will definitely be exothermic, because the right hand side forming a bond on the right hand side will involve more energy than the left hand side in this case. Whatever reaction, as long as it's similar kind, it will always be exothermic. It's a matter of how exothermic. So my explanation here is the combustion becomes exothermic, okay, more exothermic down the group, because this is observation stating the trend. The molecular size increase, which is true molecular size increase. They are breaking and making of more similar bonds, much more similar bonds, all right, and leading to greater enthalpy change. it's not just about percentage of carbon. Okay, it's hard to explain, but if you're forming and breaking a bond, if you form much more bond of similar kind, if the bond are different then you cannot compare because bond energy are different. But if the bond is a similar type, energy is similar, same amount of energy for each bond, but you form much more bond here, definitely you will be more greater enthalpy change. So that's the explanation. Alright, you can calculate the actual enthalpy change actually. You realize this is more. So next one. Describe the trends for two other properties of alcohol, which is of course mentioned in the notes earlier, which is the boiling point increases down, obviously. This is not mentioned, but this is a data question, so you just need to analyze and think of enthalpy change to explain. The one memorized one is melting point, boiling point increases, as well as solubility decreases. Remember, we mentioned that alcohol, they are very soluble if it's a small molecule. As it becomes larger molecule, the alcohol is not that soluble. Solubility decreases. Alright. So, let's move to the second part here. Okay, I should pause for a while. You try to work on this first. Okay, so I hope you have tried this thing. So these two structure given, these are the structural formula, and at one look you know that they are totally different structure. Why? Because I have oxygen here, and this actually is an alcohol. But this oxygen here is not attached to anything except the carbon. So this is called ether. Okay, you never learned this, but it's okay. Oxygen between carbon is called ether. Dimethyl, isn't this methyl? Ether. Dimethyl ether. Now, are they isomers? So please check the molecular formula. So in your explanation, you must state the molecular formula, which is this. You see that? Okay, I'll highlight here. So you work it out. C2H6O. Alright? Don't write other form. You must put all the carbon, all the hydrogen, and oxygen together and only show 3 elements. So I can say that they both have same molecular formula of this. Remember I mentioned this, if not we get penalized. But different structure formula because it is shown. So if I want to emphasize it as shown in the question. So I try to show that I understand that molecular formula work out like that, all same, but structural formula different. And very interestingly, if you have the same molecular formula when you do combustion, you get back exactly the same thing. Now, so how do I write equation to show combustion of the two compounds? Do I use a molecular formula? You don't need to use molecular formula. Remember, write equation, you can show the structure inside show the functional group inside the molecule. Yes, you can do that. Look at this. Alright, so okay, let me put it up there. Easier to see. Okay, can I move? Yeah, put it up here. So I want to emphasize that, do you realize everything is the same? I don't need to look at the rest, I just need to look at the formula. Look at this. This is the ethanol. So instead of putting CH3, CH2OH, I put C2H5OH. This is you can put this formula as the formula in the equation. No problem. Don't need to put the molecular. If you put molecular, I tell you both look identical already. So since they ask you to write the two equations, likely they want you to show this one like this. While the second one here, there's no choice, right? There's O here. So I put a CH3O CH3. That's how I write this formula. Okay? Yeah. No need to split out this CH3, CH2OH, no need. Just put C2H5OH. And then you must have everything else identical. Why? Because they are same molecular formula. What else can you expect? Okay? So that's the answer for writing the equation for the two compound. Alright, so there are actually more families that we never know, but in the question, in O-level question, sometimes they can come out different kind of family you never learned before. They can even give you the general formula, or they can give you the structures and ask you to derive general formula. Those are some application question that you have to actually learn how to do. Okay, yeah, you probably get to see some of those questions later on. Alright, looks like we have finished this topic. Okay, I would suggest that maybe you should do this question as homework. Yeah, try through the question, then maybe you can go through the next time.